let's look at a case where they've told us that z minus z1 is meant to equal to z minus z2. So z1 and z2 are fixed complex numbers that are given. And z is our point that's resulting in the locus. Okay, so if we're thinking about this in terms of distances, I want you to think back to our normal graphing. When we have 2 points, if I have 2 points, point A, point B, and our normal locus question would have asked, find the equation of the point, the locus of a point P, such that BP equals BA. What did we do before? We let P equal to XY. We'd square this so we wouldn't have to worry about square root signs. And then use the coordinates of A and B, equate the two distances, and solve. Now this is good. This can be done because we end up with square roots on both sides. We square both sides and it all works out really neatly. So we apply exactly the same method for graphing these questions, and you end up with a perpendicular line bisecting AB, or in this case, A and B would represent the vectors Z1, Z2, and P would represent the vector Z. What about the case where things aren't so straightforward? Let's look at Z plus Z1 plus Z plus Z2 equals a constant C. Now you might be tempted to do what we did in the first part, in the part above I should say, where you'd look at the distance formula here plus the distance formula equals C. The problem here is when you square the left hand side and the right hand side, you continue to end up with a square root sign. So, and it can be done, but it's a very challenging exercise to get through. So let's look at this question slightly differently. What are we saying here? Let's say Z1 is represented by the point A, and Z2 is represented by the point B, and our locus is represented by the point P. I am going to draw a very simplified example of this on an argand diagram. Let's say it just happens that A and B are these points. And what we have is some point P, and PA plus PB equals C, constant. Now we've seen this somewhere else. We've seen this in conics, where the distance from our two foci to the point P is a constant. So because I've already done this in conics, I know my result is going to be an ellipse. Now, if the question's straightforward, then A and B will be on the x-axis, and they'd be equidistant, say 3 and -3. But it doesn't matter. This equation, this relationship represents an ellipse. Where our foci lie on Z1 and Z2. And remembering that for our ellipse, PA plus PB equals 2A, where A is the x-intercept, that would mean that in this case, our major axis has a length C. And then from that, we can continue on to work out all our other details.